You have taken the radius of curvature plus 4 centimeter now. The focal length will be taken as plus 2 centimeter. Am I right? Right? The first case will be object at infinity. So you are having object distance to be taken as minus infinity. So you will be having 1 by v plus 1 upon minus infinity is equal to 1 upon focal length. Focal length is given to you plus 2 centimeter. So image distance will be taken as plus 2 centimeter. Right? Magnification will be taken as equal to minus of v. The value of v will be taken as plus 2 divided by minus infinity. So you will be having this to be taken as 0 only. So this will be less than 1. M is going to be less than 1. Right? So from this I can write down that you are having M positive. M turning out to be positive in this case. M is positive. What is the meaning of positive? You are having here image formed at focus. Am I right? Image will be formed at focus. You will be able to have the image a line towards the focus. So you will be having the first ray directed towards the focus here. As it is directed towards the focus, it will be moving parallel to the principal axis. So I can extend as if the line is coming, the light is coming along this straight line here. Your image distance is 2 centimeters, so finally the image will be formed at the focus. Image will be formed here. The second ray, I can consider it to be directed towards the pole. Parallel to this one, I will be having this ray parallel traveling to the pole here. From the pole, it will be directed along this direction. If you extend it in a backward direction, this is the position of the image. This is how I can show the figure here. The description has been given there. No, the value of M kitna aa raha hai? It is coming very much less than 1 na. If it is coming less than 1, so it cannot be magnified. M is negative, iska matlab hota hai it is an inverted image. M is positive, uska matlab hota hai image is erect. इसलिए मैंने यहाँ पर लिखा था erect image मिल रहा है, virtual मिल रहा है, because it is on the inside the mirror, so it's a virtual, and you are able to get it as diminished. So here I am taking some value which is approximately minus 6 centimeter from the pole. So if you are taking it as minus 6 centimeter, you are able to have here the relation 1 by v plus 1 upon minus 6 is equal to 1 upon plus 2. So you will be having 1 by v is equal to 1 by 6 plus 1 by 2 multiplied by 3 divided by 3. So you will be having 3 plus 1, that is 4 by 6. So answer would be v is equal to 6 by 4 that will be 3 by 2, that is 1.5 centimeter positive. So magnification M will be taken as equal to minus of V by U. So it is minus of V, the value is taken as plus 1.5 divided by U, that is minus of 6. So if you look at this, you are able to have this relation as 1 upon 4. So this is less than 1. So again it is a diminished image. So you will be able to write down here that image will be diminished, then you will be having the image formed at what distance? 1.5 centimeter. So from the pole to the right, so it is image is formed. So I can write down image is diminished, plus 1 से आ रहा है, यानी plus value आ रहा है उसका मतलब it is virtual and erect between pole and focus. क्योंकि आपका 1.5 सेंटीमीटर आ रहा है, फोकल लेंथ प्लस 2 सेंटीमीटर है, so it will be between pole and focus, right? So if that is the situation, what would happen? So you are taking minus 6 centimeter, so you will be having this taken as plus 2 centimeter. This is taken as plus 4 centimeter. This is 1 centimeter, half of it will be somewhere here. This is the position where you are likely to see the image. क्योंकि मेरा आंसर आ रहा है इमेज डिस्टेंस के लिए 1.5 सेंटीमीटर, द इमेज डिस्टेंस इज 1.5 सेंटीमीटर, सो आई विल बी एबल टू मार्क इट एज 1.5 सेंटीमीटर एज द इमेज. सो दिस इज द पॉइंट वेयर आई विल बी एबल टू गेट दिस एज प्लस 1.5. Now I am having at 6 centimeter, so this is actually 4 centimeter, so equal distance I will be having this as 4 centimeter. Somewhere here I am placing the object. So from here this object distance will be taken as minus of so first ray will be moving parallel to the principal axis. It will be appearing to you to be passing through the focus, but it will be reflected back along this direction. I can have a second ray directed towards the focus, or directly I can take a second ray directed towards the pole. Here the ray would be getting reflected along this direction. If you extend it here, you are able to get a diminished image, and that diminished image is lying between pole and focus. Yeah. No, actually that is not the reason. You can take any value. No, you can take even -2. Because, look, this is a very important point. There is a question why I have taken -6 centimeter. Because in case of a concave mirror, we have taken it as -6 centimeter. Therefore, I have taken here -6 centimeter. But it is saying that it is between the center of curvature and infinity. Center of curvature is present here, infinity is present here. So even if I am taking minus 1 centimeter, I will never have a problem. I can take here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, any number. Because my center of curvature is on the right. In the concave mirror, the center of curvature and infinity, that were minus 4 to infinity. That is the reason in concave mirror I have taken it as minus 6 beyond center of curvature. But here you can take even minus 1 centimeter. There will be no issue because center of curvature is on the right side and infinity is on the left side. So minus 1 centimeter from the pole will be also the distance between center of curvature and infinity. You cannot take positive because object will be then inside the mirror. Then it will be a virtual object. मिरर के सामने खड़ा रहना पड़ेगा ना इमेज देखने के लिए कि मिरर के पीछे जाके इमेज देख रहे. So how many conditions I have asked you to work for? So अभी आगे के दो. Why? Wherever? क्यों? कैसे रहेगा सेम? इंफिनिटी का ले लिया, बिटवीन इंफिनिटी एंड सेंटर ऑफ कर्वेचर ले लिया. कैन आई टेक द ऑब्जेक्ट एट फोकस? व्हाई नॉट? बट द सब्जेक्ट गिव्स यू दैट लिबर्टी टू यूज द वर्ड वर्चुअल ऑब्जेक्ट. Do you remember we have used the word virtual object? Real object produces the virtual image. The virtual object will produce the real image. Try it out. So in that case, you will be taking the object distance to be equal to I am taking it as focus, so it will be plus 2 centimeter. The focal length will be also plus 2 centimeter. So you will be having 1 by v plus 1 by u is equal to 1 upon f. This is the virtual object case. This is virtual object. So you will be having this as 1 upon v plus 1 upon plus 2 is equal to 1 upon plus 2. So you will be having 1 by v is equal to 1 upon 2 minus of 1 upon 2. So it will be 0. So image will be formed at infinity. तो यही तो हमने प्रूफ किया है. When the object is at focus, the image will be at infinity. Object is virtual here, so image will be real. Just check the copies. We have talked about it. We have talked about it that real object, real image, virtual object and the real image the other way. Plane mirror में हमने देखा इसको. So once you are able to get that, magnification can be calculated. M is equal to minus of v by u. So you will be having this as minus of infinity upon u. U is plus 2, so that will be taken as equal to minus of infinity. So magnification is minus infinity, मतलब real image will be formed. Real, inverted, magnified. बन सकता है diagram. Only I have to say that the object is virtual. Image will be real, inverted, and that too magnified. Inverted or erect. Invert and erect. Virtual or real will depend upon if the image is formed inside the mirror, it will be virtual. In front of the mirror, it will be real.
Sir, I'm asking how to come to the size of this property to indicate that size that is starting place.
The value, like in one of the cases here, m is turning out to be 1 by 4. So m is 1 by 4 means size of image upon size of object is 1 by 4. So object size is bigger, image size is 1 by 4. So it is less than the size of the object.
So magnification it indicates the size of the object.
Size of image.
Size of the if it is negative,
Then it will tell you that it is an inverted image. If m is positive, then it is an erect image.
sir, I got your point that it is inverted or erect. I am saying like how I come to like this.
You look at minus 1 by 2 अगर है वहाँ पर, तो 1 by 2 is telling you that size of image upon size of object is 1 by 2.
The magnitude is
Yeah. Object is placed at focus. Now this object which is placed at focus will be called as virtual object, and for that virtual object real image will be obtained because you are getting the magnification as negative. So that is formed at infinity. You can calculate that. U is equal to plus 4. Yes. But that object will be called as virtual object. And for that virtual object, you are trying to find out the image. Okay? In front of concave mirror or a convex mirror that can be analyzed. Have you got it? So in a way, how many figures are there? Only 8. In a convex mirror, always there will be a virtual image formed. Yes or no? At any point between infinity and center of curvature, what type of image will be formed? It will be a virtual image. Will it be a erect image? Inverted रहेगा या erect रहेगा convex में? It will be always erect and it will be diminished. It will never be of the size of the object or bigger than the size of the object. Am I right or not? Right? Whereas in concave mirror, you are able to see that initially when the object is moving from infinity to focus, you are able to get the inverted image, you are able to get the real image, you are able to get the magnified images, because at infinity it will be giving you the point image. Object at infinity will produce the point image at the focus. But when you start from infinity to the center of curvature, the size of the image goes on increasing. When it is at center of curvature, the size of image and size of object will be equal. Between center of curvature and focus, the size will be increasing. At focus, it will be maximum. But beyond focus, you are able to see that it will produce a virtual magnified image. Am I right or wrong? Sure? Getting it? So convex mirror always produce which type of image? Virtual image. And concave mirror will produce real inverted. And if you are having the concave object between the focus and pole, then only it will produce. Are you all getting it clearly? This property is used to identify the mirrors. Not the concaveness, not the nor the convexness. Because concaveness and convexness are very little in actual mirror as compared to the ray diagrams that we are showing. And that is the reason in the beginning I have shown you both the concave and convex mirror and I have asked you to identify. So I'll now show you how to identify concave mirror and convex mirror. We are having few aspects here that are to be covered related to the same discussion. So we'll just go for the points there. Now it's a point that I will be discussing by stating some condition, and I'm expecting the answers from you with the background that we have created. So write down first point. For real extended object, if the image formed by a single mirror is erect, for real extended object, if the image formed by a single mirror is erect, comma, it is always, fill in the blanks. So whenever you are able to see the image that is erect, that image will be, write down, virtual is the correct answer. It is always virtual. In a bracket, write down small m is, fill in the blanks. You are writing about erect, it is always virtual. So what will be the value of m? M is positive, negative, 0. So you should mention there m is positive. And in this situation, if, point number 1, size of image is smaller than object, then mirror is, fill in the blanks. Correct. Then mirror is, all of you are getting it? So it will be convex. Second point, the size of image is equal to the object. Size of image is equal to the size of object. The mirror is, tell me one thing, in case of concave mirror, are you going to have a erect virtual image? Under what condition it will have? When the object is present between the focus and the pole, then you are getting the erect virtual image, but that will be magnified. I am talking about the size of image equal to size of object. So it will be a plane mirror. Third point, under the same, if the size of image is larger than object, the mirror is, so all of you are aware that where will be the position of object in case of concave mirror? Between F and T. So mention there, between F and T. So can you use this property to identify the different mirrors, plane mirror, concave mirror, convex mirror? Can you use this property? So that is why this property has been given to you, that without looking at the curvature, how can you judge it? Between focus and pole you keep it. If it is magnified, it is a concave. If it is diminished, then it will be a Convex. If it is of equal size, then it will be called as plane mirror. Second point. Next, next point. For real extended object, comma, if the image formed by the single mirror, is inverted, comma, it is always fill in the blanks. You are asking a question or giving the answer. If you say real, it's a question. Real, it is an answer. So answer is real. It is always real. In a bracket, small m is negative. Comma, the mirror is concave. In this case, the mirror will be concave. In this situation, if the size of image, point number 1, is smaller than the object, which mirror we are talking about? Concave. Tu so raha hai kya re? You have written there concave. So you are having here if the size of the image is smaller than object, where will be the object present? Only at infinity. Beyond C. बराबर है. So mention there, object is between infinity and C. Object is between infinity and C. And where will be the image? Where will be the image? Yes, it will be between F and C, because when your object is at infinity, image is at focus. When you are bringing the object to the C, your image will be also coming to C. So when the object is moving from infinity to C, the image will be moving from focus to C. Getting this? It's already written with you. You just have to look at the table. You will get the point. Object is at infinity. Where will be the image? At the focus. So when you are bringing the object from infinity towards C, the image will be moving from focus to C. When object is at C, image will also be at C. So when the object is traveling from infinity to C, the image will be traveling from focus to C. Got it clearly? Second part of the same part, second part, the size of image is equal to the object. Correct. Object is at C. Image is also at C. So what will be the minimum distance between the object and image? Very true, it will be 0. So remember, the minimum distance between the object and image in case of a concave mirror, when object is at C, is equal to 0. Okay? Third part, if the size of image is larger than the object, object is between, very true, C and F, object is between C and F, and image is between, beyond C up to infinity. So image will be between C and infinity. Now, you are having the second condition on the board, right? Suppose I cover this particular portion of the mirror by a black paper. Half of the mirror is covered with a black color. What would happen? Something will happen, definitely. So do you remember we have seen in a plane mirror similar situation? What happened there? Only intensity of the image got decreased, but the complete image was formed, right? So in this case, you have to mention there, write down the next point, as every part of the mirror forms a complete image. As every part of the mirror forms a complete image, comma, if part of the mirror is obstructed, full image will be formed, but intensity will be reduced to half. Full image will be formed, but intensity will be reduced to half. You have half obstructed, so intensity will be half. If you have 1/4 obstructed, the intensity will be 3/4. If you are having half is obstructed, then intensity will be half. If you are obstructing 1/4, then intensity will be 3/4. If you are obstructing 3/4, the intensity will be 1/4. That relation must be known to you. Okay? Now, you have to describe the speed of image if the object is moving from infinity to the pole at a constant speed. Object is moving with a constant speed towards the pole, from infinity to the pole. What will be the speed of the image? Shame. Shame, shame. How it could be same? So you said same. How speed can be same? Again, you are not working with the data that you have created in last 2 hours. When object is at infinity, where is the image? Focus. So object is starting from infinity with a constant speed and is coming to the center of curvature. Where will be the image? Image, when the object is at infinity and is moving to the center of curvature, the image will be moving from focus to the center of curvature. So you can say that initially the image is moving very, very slowly. Am I right or not? And the moment the object crosses the center of curvature towards the focus, the image begins to travel beyond center of curvature to the infinity. So if object is moving slowly or with a certain velocity, image will be moving very rapidly after the center of curvature. So here the velocity or the speed doesn't remain constant, it goes on varying. When object moves from infinity to center of curvature, image is moving slowly from focus to the center of curvature. When object begins to travel from center of curvature to the focus, image will appear to you from center of curvature to the infinity. So initially speed of the image is slow and later on it is very fast. This is how the relationship of object speed and image speed is there. Got that point? Mention it as a point there. If an object is moved at constant speed, if the object is moved at a constant speed, towards a concave mirror from infinity to the focus, comma, the image will move slower in the beginning, and faster later on, away from the mirror. This is because in the time the object moves from I am again repeating it. If an object is moved at a constant speed towards a concave mirror from infinity to focus, comma, the image will move slower in the beginning and faster later on, comma, away from the mirror. This is because in the time the object moves from infinity to C, the image will move from F to C. And when object moves from C to F, the image will move from C to F, the image will move from C to infinity. At center of curvature, speed of object and speed of image will be equal. At center of curvature, speed of object and speed of image will be equal. Write down a point there. 90% of this point which you are going to write down, you will be able to understand. 10% में दिक्कत जाएगी. When it will be there, you raise a question, I'll answer that. Okay? But mention this point. As focal length of spherical mirror small f, as focal length of a spherical mirror small f equal to capital R by 2, depends only on the radius of the mirror. Do you agree to this part? Focal length is given by R by 2, so focal length depends on the radius. Right or not? And is independent of wavelength of light and refractive index of the medium. Wavelength of light and refractive index of the medium. So the focal length of a spherical mirror in air or water is same. The focal length of spherical mirror for different color of light is also same. the focal length for different colors is also same. This is also why the images formed by the mirrors do not show chromatic aberrations. ABERRATION. Aberrations.
So I said to you that 90% you should be able to understand. 10% there may be some questions in the mind. Aberrations का मतलब चाहिए. Okay. Now I'll put it like this.
Normally, all the rays are meeting at a particular point. If refractive index would have been playing the role, then for different color of light, the position of formation of image would have been different. Like in a prism, you are able to see that when a white light is passed, it splits into the 7 colors. Right? Constituent colors में वो split होता है. But in the image formation, if different white light is made incident, then different colors of the white light will form the image at different positions. They will not be forming the image at one position. So you will be able to see multiple images out of it, and that is known as aberration. Chromatic is the word. Chrome is standing for color. So due to the different colors, there is a different position of image obtained. But this is not seen in case of a plane, in case of the spherical mirror, which is likely to be seen in case of the lenses. So chromatic aberration is a property of lenses, not of the mirror, because in case of mirror, focal length only depends on radius. It is independent of refractive index, it is independent of wavelength, and that is why chromatic aberration do not take place in case of a spherical mirrors. Okay? Now, so can you tell me the formula for the mirror? जोर से एक साथ बोलो. माइनस लिखना है क्या? So avoid minus. That will be there. When you write down the formula for the lenses, it turns out to be 1 by V minus 1 by U is equal to 1 by F. So that difference you should remember whether you are writing for a lens or for a mirror. So for a mirror it is plus only. What is the formula for focal length? R by 2. Now if you are having radius of curvature tending to infinity, what will be the focal length? Infinity. If focal length is infinity, can I write down 1 by V plus 1 by U is equal to 0? So I will be able to write down 1 by V is equal to minus 1 by U. So you will be able to write down V is equal to minus of U. Have you seen this situation? किसकी बात कर रहा हूं मैं? You are mentioning here that radius of curvature is tending to infinity. The radius here is small, radius is increasing and it is tending to infinity. So it will be appearing to you like this only. So which mirror it is? And you were talking about concave and convex. So when I am writing that radius of curvature is tending to infinity, the nature of the mirror would become a plane mirror, and in case of plane mirror, image distance is equal to negative of object distance. Object and images are at an equal distance from the plane mirror. Have you seen this point? So we are able to derive the same. यही तो लिखा है यहाँ पर. Okay? So mention there all these points. कि what would happen